Hi, I'm going to be giving a series of videos here for Chapter 8, mostly Section 8.2, but I will do one homework problem from Section 8.1 to show how to find Laplace transforms using the definition when you integrate from 0 to infinity. So this is Part D of Question 1, where we're supposed to find the Laplace transform of e to the 2t minus 3e to the t. And by definition, that means you integrate from 0 to infinity of e to the negative st times that little f of t that's given. And to avoid writing out all of the limit symbols repeatedly before we actually need to take the limit, I'm just going to first find an indefinite integral. And I rewrote the function right here, and I'll give you a second to calculate that yourself if you want to, and then we'll proceed. I'm going to write out the steps for the indefinite integral after I've rewritten it as shown here. So in the yellow box I have taken the indefinite integral with no bounds. Just took the antiderivative of each piece. Remember that the antiderivative of e to the kt is just 1 over k times e to the kt. And so my new exponent here, by combining terms, for the first part was negative s plus 2 times t, and on the second was negative s plus 1 times t, just by using properties of exponents to rewrite it. So then I have two separate antiderivatives to take, and those are shown here in the second row inside the yellow box. And once I have that antiderivative, to go back and evaluate this improper integral from 0 to infinity, by definition, what that means is we integrate from 0 to t, and then take the limit as t goes to infinity. So since this was the antiderivative, I have that inside these brackets here, and I'm going to evaluate that from 0 to t, and then I'll take the limit. So I'll write that all out now. Alright, so up in this previous part, I just replaced little t by capital T here, and then I replaced little t by 0 and subtracted the 2 on the left-hand side. And then I did the same thing on the right-hand side. And so we get this following, and we will evaluate this as t goes to infinity. And we won't really need to use L'Hopital's rule because this negative s plus 2 is just a constant, the negative s plus 1 is just a constant, and this e to the 0 is a constant. So the analysis comes down to this first part, e to the negative s plus 2 all times t. And as long as that coefficient on t is positive, is negative, then the whole exponent will be negative because t is going to infinity, so t is a positive number. So as long as that whole exponent is negative, this limit is going to be 0. And that'll be true as long as s is bigger than 2. So this is just going to equal negative 1 over negative s plus 2. That's the first one, because this limit here will be 0. Right? That's the limit's going to be 0. Minus 3, same thing here. That's going to go to 0 minus 1 over negative s plus 1. So we get negative 1 over negative s plus 2 minus 3 times negative 1 over negative s plus 1, which equals, let's see, that'd be 1 over s minus 2 plus, let's see, I want to make that an s minus 1 here, so I guess I should make that a negative 3 still. And this limit over here was good as long as I needed s to be bigger than 1, because I want this coefficient in front of t to be negative, and as long as s is bigger than 1, that'll be Negative s plus 1 is going to be negative, and over here I need s bigger than 2. So together, for both of those to happen, for each of those to go to 0 as I have here and here, I need to have s bigger than 2. And it's going to diverge if s is less than or equal to 2. So here is my answer. And that'll be f of s is my Laplace transform. It's a function of s. It's only really defined to be it's infinity otherwise, but it's a finite number as long as s is bigger than 2.